Section 1.3, Topic 3, The Scientific Method. Although two scientists rarely approach the same problem in exactly the same way, they use guidelines for the practice of science that are known as the scientific method. These guidelines are outlined in Figure 1.15. We begin our study by collecting information, or data, by observation and experiment. The collection of information, however, is not the ultimate goal. The goal is to find a pattern or sense of order in our observations and to understand the origin of this order. As we perform our experiments, we may begin to see patterns that lead us to a tentative explanation or hypothesis that guides us in the planning further experiments. Eventually, we may be able to tie together a great number of observations in a single statement or equation called a scientific law. A scientific law is a concise verbal statement or a mathematical equation that summarizes a broad variety of observation and experiences. We tend to think of the laws of nature as the basic rules under which nature operates. However, it's not so much a matter that matter obeys the laws of nature, but rather that the laws of nature describe the behavior of matter. At many stages of our studies, we may propose explanations of why nature behaves in a particular way. If a hypothesis is sufficiently general and is continually effective in predicting facts yet to be observed, it's called a theory. A theory is an explanation of the general causes of certain phenomena with considerable evidence or facts to support it. For example, Einstein's theory of relativity was a revolutionary new way of thinking about space and time. It was just more than a simple hypothesis, however, because it could be used to make predictions that could be tested experimentally. When these experiments were conducted, the results were generally in agreement with the predictions and were not explainable by earlier theories. Thus, the theory of relativity was supported, but not proven. Indeed, theories can never be proven to be absolutely correct. As we proceed through this text, we will rarely have the opportunity to discuss doubts, conflicts, clashes of personality, and revolutions of perception which have led to our present ideas. We need to be aware that just because we can spell out the results of science so concisely and neatly in textbooks, it doesn't mean that the scientific method progress is smooth, certain, and predictable. Some of the ideas that we present in this textbook centuries to develop and involve many scientists. We gain our view of the natural world by standing on the shoulders of the scientists who came before us. Take advantage of this view. As you study, exercise your imagination. Don't be afraid of daring to ask questions when they occur to you. You may be fascinated by what you discover. Figure 1.15, the scientific method. The scientific method is a general approach to solving problems that involves making observations, seeking patterns of the observations, formulating hypotheses and explain the observations, and testing these hypotheses by further experiments. Those hypotheses that withstand such tests and prove themselves useful in explaining and predicting behavior become known as theories.